Welcome to the last day of fractions for this chapter. And what a special day. We get to mix our fractions with some exponents. How exciting is that? But before we do that, before we mix in the fractions, let's just do a little review with our whole numbers. So we've had problems that look like 4 times 2 to the third power, which really means 8 to the third power, which really means 8 times 8 times 8. So when you look in your notes and the boxes on there, the first one looks really scary with all those parentheses, which is just basically a trick. What does it mean when the 2 and the 3 are smushed together? 2 times 3 to the third power. What does that mean? 6 to the third power. What does that mean? 6 times 6 times 6. I have 3 6s. 6 times 6 is 36 times 6. $216. Now, of course, we don't always just have numbers. Variables mix in. Of course, variables mix in. This is 7th grade. So, the second box, 2 times p to the 4th power. For 2 times p's. And then somewhere along the line, someone remembered, well, can't I go out of order when it's multiplication? Yes, of course I can. So let's take all of these 2's and put those next to each other. And let's take all of these p's and put those next to each other. So I really have 2 to the 4th and p to the 4th. Like, look at this. 2 to the 4th and p to the 4th. Crazy. So the third one would really be x to the 5th, y to the 5th. It's kind of like a shortcut. I didn't need to write out all those x's and all those y's. The last one would be 5 to the 2nd and x to the 2nd. And then you may be wondering, well, can't I solve some of that? Yes, actually, we can. 5 to the 2nd is 25. 2 to the 4th is 16. So yes, if there are numbers, we can go ahead and solve them. If you look to the next boxes, there was some things about the exponents and the negatives. What is different about these two problems? They look very similar, except for the negative is on the inside of one and the outside of the other. On the left one, negative is stuck with 5, stuck like glue. On the right one, the negative is not stuck. I have 5x and I have 5x, but the negative is not stuck. It's just outside the whole time. What's a negative times a negative? When the negative is on the outside, it doesn't get touched. It just goes all the way down to the answer. This would be a good time to try the next 2 boxes on your own. Ready, go. Again, what's the difference? On the far right one, negative is stuck with the 5. On the left one, the negative is not stuck to anything. It doesn't go with any of the numbers. 2 times 2 times 2 times 2. How many y's are there? Negative stays in front, untouched. How many A's are there? 1, 2, 3. How many B's are there? 1, 2, 3. I do have to do a little bit of math with these negative 5's. With 5's, I just think of quarters. So that was just a little bit of a review with whole numbers and variables so that we can move on to this fraction and exponent piece. Again, I like to ask this question. It frustrates some 7th graders. What does this mean? It means I have 4/5, 4/5, 4/5, 3 times. You may have heard me say this before. Stretch it out, stretch it out, stretch it out, stretch it out. I stretched it out. How do I multiply fractions? Straight across the top, straight across the bottom. 4 times 4 times 4, 5 times 5 times 5. Think of quarters again. So I don't have to panic when there is a fraction and an exponent. I just stretch it out and multiply straight across. Go ahead and pause and try some of these. not stretching it out, that's your first mistake. I move the negative to the top of that one. There's nothing scary about stretching it out. Now, multiply across. 1 times 1 times 1, 1. 2 times 2 is 4 times 2 is 8. Not scary at all. Just multiplying straight across. Not scary at all. 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. How many m's? 1, 2, 3. 5 times 5 is 25. 5 quarters. Not scary at all. The next two are, I will admit, a tiny bit scary, but not impossible. What's first, exponents or adding? Oh, exponents, you say? Stretch it out. Three times 3 is 9. 4 times 4 is 16. Plus, how do I add fractions again? Oh, I know. Common denominator. Add the top. Keep the bottom. Simplify. Notice I only had one problem on this screen because I needed a lot of space to work and think. Don't try to smush it all in there. Not a good idea. You are ready to pause and work. What's first, exponents or subtracting? Exponents, you say. Stretch it out. We've done 5 times 5 times 5 a lot already. Did you memorize it? Six times 6 is 36 times 6. What in the world? A common denominator? Oh, I know. bottom, subtract the top. Again, notice I didn't have a lot of extra space. I had to use a lot of writing and thinking. Last two, go ahead and pause and work. Two to the second is 4. Stretch it out. I have a 2, and I have a third. What's first, parentheses or exponents? Parentheses, you say? Two thirds to the second power, stretch it out. Multiply straight across. You can do this. You got it. Have a good one.